Hi everyone, today we're going to be looking at derivatives of trigonometric functions applications. So we're going to be looking at writing equations of tangent lines, finding relative extrema, and looking at particle motion. So for this first one, we have write the equation of the tangent line to y equals cosecant x at x equals 3 pi over 4. So I know that as soon as I see the word tangent line, I'm going to need to find a derivative. So if y is equal to cosecant x, and I take a derivative, the derivative of cosecant x is negative cosecant x cotan x. When I write the equation of a tangent line, I'm filling in the point slope formula of a line, which is y minus y1 equals m times x minus x1. I know that x1 and y1 come from my original equation y, and I know that m is the slope of the tangent line, which comes from the derivative. So I'm first going to find m tan. Since I'm finding the slope of the tangent line at x equals 3 pi over 4, I plug 3 pi over 4 into the derivative. So I have negative cosecant 3 pi over 4 times cotan of 3 pi over 4. I'm going to leave that negative here, and I'm going to evaluate cosecant of 3 pi over 4 and cotan of 3 pi over 4. So I know that sine of pi over 4, so I'm ignoring this 3 in the numerator. I know that sine of pi over 4 is rad 2 over 2, but since this is cosecant, I'm going to flip that. So I'm going to write that as 2 over rad 2. I know that 3 pi over 4 is in ASTC. So if I set up my little chart here, minus 1 plus 1 times 2 minus 1. So 3 pi over 4 is in the second quadrant, which means sine is positive. For cotan of 3 pi over 4, I know that tan of pi over 4 is 1, so cotan of pi over 4 is also 1. And in the second quadrant, cotan or tangent is negative. So this is a negative 1. Negative, negative gives me a positive, so I have 2 over rad 2 as the slope of my tangent line. I'm going to need this in a minute. So that's my m value. I already have x up here. So the only thing I'm missing is y. And y comes from our original function. So I need to evaluate cosecant of 3 pi over 4. We just figured out up here that cosecant of 3 pi over 4 was 2 over rad 2. So that is my y1 value. All I have left to do is to plug these 3 values into the equation of my line. So I have y minus 2 over rad 2, y minus y1 equals m 2 over rad 2 times x minus x1, and x1 was 3 pi over 4. There is the equation of my tangent line. Number 2. Given the position of a particle s of t is negative 1/2 cosine of 2t, find a whole bunch of stuff. So let's start with A. Find the velocity of the particle at t equals pi over 2. So for part A, I'm finding the velocity at t equals pi over 2. Remember that velocity is equal to the derivative of position. So s prime of t is equal to v of t. I'm just going to rewrite my s function down here so it's easy when I take a derivative. So negative 1/2 cosine of 2t. I keep the negative half. The derivative of cosine is negative sine, leave the 2t, and the derivative of 2t is 2. The 2 and the negative half cancel out. Negative times a negative is a positive, so v of t is equal to sine of 2t. I need v of pi over 2. So that's sine of 2 times pi over 2, which is equal to sine of pi. And I know that sine of pi is 0. Part B. Find the average velocity from t equals 0 to t equals pi over 2. Remember that average velocity is equal to slope of the position function. So I'm actually looking for the slope of the position function from t equals 0 to t equals pi over 2. So I need to find s of pi over 2 minus s of 0 over pi over 2 minus 0. So I'm going to find s of pi over 2 and s of 0 on the side. So if I do s of pi over 2, that is negative 1/2 times cosine of 2 times pi over 2. So that's negative 1/2 times, the 2's cancel out. Cosine of pi is negative 1, so I end up with positive 1/2. For s of 0, I have negative 1/2. Cosine of 2 times 0 is just cosine of 0. So that's negative 1/2. Cosine of 0 is 1. I end up with negative 1/2. Plugging those two values in here, I have 1/2 minus negative 1/2 over pi over 2. 1/2 minus minus becomes plus plus, so I have 1 over pi over 2, which is equal to 2 over pi. So that is the average velocity from t equals 0 to t equals pi over 2. Part C, when is the particle moving left on 0 to pi? If I'm looking for when the particle is moving left, I'm looking for when the velocity is less than 0. So I'm going to take that velocity function that I found in part A, and I'm first going to set that equal to 0. I know that sine is equal to 0 at pi and 0. So I'm going to let 2t equal 0 and 2t equal pi, and then solve for t in both scenarios. So I have t equals 0 and t equals pi over 2. And now I'm going to stick those on a number line. So the interval that they gave me is 0 to pi, so I do have endpoints on here. The only critical value now that I can put in here is pi over 2. Now, if I test values in here to figure out positive and negative, let me also label this V so I know what I'm plugging into. So I'm plugging into V. If I choose something between 0 and pi over 2, say I pick pi over 4, 2 times pi over 4 is pi over 2, and I know that sine of pi over 2 is positive 1, so I'm positive in this section. If I pick 3 pi over 2 in this section, 2 times 3 pi over 2 is just pi, and sine of pi is negative 1, so I'm negative in this section, which means that my particle is moving left from pi over 2 to pi. Now, I definitely don't include these endpoints because I know that at pi over 2, my particle is changing direction, so it's not moving right or left. And then I don't include pi because that's an endpoint on my graph. Part D, when is the velocity of the particle decreasing on 0 to pi? If I'm looking for when the velocity is decreasing, that means I'm looking at a velocity graph and I want to know when it's going down. So I need to look at the derivative of velocity. The derivative of velocity is acceleration. So I'm actually looking for when acceleration is less than 0. I know that acceleration is the derivative of velocity, so I'm looking for the derivative of sine of 2t. The derivative of sine is cosine. I leave the 2t. Times the derivative of that angle, the derivative of 2t is 2. I'm going to set that equal to 0 to find my critical values. I know that cosine is equal to 0 at pi over 2 and 3 pi over 2. So if I solve for t in each scenario, I'm going to get pi over 4, and I'm also going to get 3 pi over 4. I'm going to stick those on my number line. From 0 to pi, this is an A number line. And the two critical values that I just found are pi over 4 and 3 pi over 4. Now, in each of these sections, if I'm looking first between 0 and pi over 4, that's in the first quadrant. I know that cosine is positive in the first quadrant, so I'm going to be positive in here. For pi over 4 to 3 pi over 4. That's in two different quadrants, so it's not as simple as what we just did here. For this one, I'm actually going to pick a value. So between pi over 4 and 3 pi over 4, I have the value pi over 2. So if I plug pi over 2 in for t, 2 times pi over 2 is pi. Cosine of pi is negative 1. 2 times negative 1 is negative 2. So I'm negative in this interval. And then if I look from 3 pi over 4 to pi, I'm only in quadrant 2. And I know that cosine is negative there. Now, for this last section between 3 pi over 4 and pi, I'm going to want to test a value in here. Now, from 3/4 to 4/4, right? I can't really fit anything in there. So I'm actually going to make a common denominator of 8 for the 3/4 and the pi. So that means this value, if I make an 8 on the bottom, is going to be 6 pi/8. And this value is 8 pi/8, which means a value that I can test between 6 pi/8 and 8 pi/8 is 7 pi/8. So I'm going to do that on the side over here. I'm going to find a of 7 pi/8 because I need to figure out if I'm positive or negative in this section. So that's 2 cosine of 2 times 7 pi/8. If I reduce this fraction in here, this is going to become a 1 and a 4. So I'm looking at 2 cosine of 7 pi/4. Now I can see this is a times 2 minus 1. So I'm in the 4th quadrant. Cosine is positive here, and it's actually a positive rad2/2. So this is 2 rad2/2. Again, I don't really care about this value. All I really care is that this is positive, and a positive times a positive is positive. So in this last section for the A graph, I'm positive, which means velocity is decreasing only from pi/4 to 3 pi/4. Number 3, given the position of a particle s of t equals cosine squared t, when is the particle moving left from 0 to 2 pi? So if I'm looking for when the particle is moving left, I'm looking for when the velocity is less than 0. Velocity is the derivative of position. I'm first going to rewrite that position formula as cosine of t squared. So now when I find the derivative, the 2 comes in front. I leave the cosine t times the derivative of cosine t is negative sine t. If I clean that up just a little bit, I have negative 2 cosine t sine t. And I'm going to set that equal to 0 to find my critical values. So I have cosine of t equals 0, and I also have sine of t equals 0. I know that cosine is equal to 0 at pi/2 and 3 pi/2. And I know that sine of t is equal to 0 at 0, pi, and 2 pi. So I have a ton of critical values here. On my number line from 0 to 2 pi, and this is a V number line. So on this number line, I have critical values of pi/2, pi, 3 pi/2, and then I end at 2 pi. So if I start checking values in here, between 0 and pi/2, I can test a value of pi/4. I know pi/4 is in the first quadrant, so both of these are going to be positive, which means I am positive between 0 and pi/2. Between pi/2 and pi, I'm always in the second quadrant here. So sine is positive and cosine is negative. So positive times a negative is a negative for this section. From pi/2 to 3 pi/2, they are both negative. Sine and cosine are both negative, and negative times a negative is positive. And then from 3 pi/2 to 2 pi, cosine is positive, but sine is negative. So I'm negative over here. Something important to note here, the difference between number 2 and number 3. In number 2 for part D, I had 2 cosine of 2t. So that angle was 2t, which is why I had to be a little more careful when I was trying to figure out the sines. But here, since I just have cosine of t and sine of t, I can just look right at my ASTC graph and go from there. I don't have to worry about plugging an angle in and then that angle actually changing, which is why I was able to just look in each of the quadrants. So now to write out our final answer, I'm moving left when the velocity is less than 0. So I'm less than 0 when the velocity is negative, which is here and here. So there's 2 intervals. My intervals are going to be pi/2 to pi and 3 pi/2 to 2 pi. Number 4, given the position of a particle s of t equals sine of e to the t, when does the particle change direction? So I know that a particle is going to change direction when v of t equals 0 and the sign changes. So the sign needs to change from positive to negative or negative to positive at a critical value. I could have a critical value and be positive, positive, or negative, negative. That's stationary point. I want to know when I'm changing direction. So not only does v need to equal 0, but the sign needs to change at that value. So first I'm going to find v. The derivative of sine is cosine. I leave the e to the t, times the derivative of the angle. The derivative of e to the t is e to the t. I set that equal to 0 to find my critical values. So I have cosine e to the t equals 0, and I have e to the t equals 0. This one's a no solution, so I don't get any answers over here. I know that cosine is equal to 0 at pi over 2. So I have e to the t equals pi over 2. And I know that cosine is also equal to 0 at 3 pi over 2. So I have e to the t equals 3 pi over 2. Now, looking at what they gave me up here, I'm only looking from 0 to pi, so I actually don't need this answer here. I'm only looking at this one. So to solve for t, I'm going to ln both sides, and I get t equals ln of pi over 2. I'm going to put that on a number line, and this is a v number line. If I test 0 in here, in for v, e to the 0 is 1. First, let me fix this critical value. So this critical value is actually ln of pi over 2. I'm going to start this at 0, and then I'm ending at pi. Now, since my critical value is ln of pi over 2, I'm going to test a value in here of ln of pi over 4, because I know that has to be smaller than ln of pi over 2, but greater than 0. So I'm first going to test ln of pi over 4. So I have cosine of e to the ln of pi over 4 times e to the ln of pi over 4. Over here, your e and your ln cancel each other out. I have cosine of pi over 4, which is positive, times e to the ln of pi over 4. Again, the e to the ln cancels. You have pi over 4, which is positive. Positive times a positive is a positive for that first section. For the section from ln of pi over 2 to pi, I'm going to test a value between pi over 2 and pi. So say I pick 3 pi over 4. So now I'm going to do v of ln of 3 pi over 4. Again, that critical value has the ln in front, which is why I stick the ln in when I'm plugging in for t. But it ends up just canceling with the e's anyway, so it's really not so bad. So I have cosine of e to the ln of 3 pi over 4 times e to the ln of 3 pi over 4. Over here, your e and your ln cancel. Cosine of 3 pi over 4 is negative, times e to the ln of 3 pi over 4 is a positive number. So a negative times a positive is negative. So what I figured out, at ln of pi over 2, the velocity is equal to 0. That's a critical value. I'm moving right from 0 to ln of pi over 2, and then moving left from ln of pi over 2 to pi. So this is a critical value, and I change signs, which means the particle does change directions at t equals ln of pi over 2. Number 5, when is the graph y equals sine of 4t concave down? So if I'm looking for when a graph is concave down, I need to know when the second derivative is negative. So I'm trying to find out when y prime prime is less than 0. I first need to find y prime. The derivative of sine is cosine of 4t times the derivative of the angle is 4. And then for y prime prime, I keep the 4. The derivative of cosine is negative sine, leave the 4t, times the derivative of the angle is 4. If I clean that up, I have y prime prime is negative 16 sine of 4t. I first need to set this equal to 0 and solve for t. So I have sine of 4t equals 0. And I know that sine is equal to 0 at 0, pi, 2 pi. If I solve each of these, I get t equals 0, t equals pi over 4, and t equals 2 pi over 4, which is pi over 2. Each of these answers is within this interval that they gave me. So I'm going to set up my number line from 0 to pi over 2 This is a y prime prime number line, and the only critical value that's going in between those is pi over 4. Now, I'm going to find common denominators for these so that I can actually find values in between here to test into y prime prime. This angle of 4t is the reason why I need to actually test my intervals out. So I'm going to find a common denominator of 8. So 4 times 2 is 8, so I have a 2 pi over 8 for this critical value, and this critical value is equal to 2 times 4, so that's 4 pi over 8. So if I pick a test value between 0 and 2 pi over 8, I can pick just 1 pi over 8. So I'm going to find y prime prime of pi over 8. So now this is negative 16 sine of, if I reduce this, I have 1 over 2. That's sine of pi over 2. And sine of pi over 2 is positive 1. So a negative times a positive is a negative number. Again, not worried about the value, just worried about the sign. Now, if I test a value between 2 pi over 8 and 4 pi over 8, I can pick 3 pi over 8. So negative 16 sine 4 times 3 pi over 8. Reduce the fraction, so I have 1 and 2. So now this is negative 16 times sine of 3 pi over 2. Negative 16 sine of 3 pi over 2 is negative, and a negative times a negative is a positive. So now looking at my number line, I can see that this graph is concave down from 0 to pi over 4. 0 to pi over 4, this graph is concave down. Number 6. Find all relative extrema of y equals secant x on negative pi over 2 to pi over 2. So when they're talking about relative extrema, that means maxes or mins, and I find those using the first derivative. First, I'm going to find the derivative of secant x, which is secant x tan x. I set that equal to 0 to find my critical values. So secant x equals 0, tan x equals 0. Remember, secant is 1 over cosine of x, and 1 over cosine x is never going to be equal to 0. Tan x is equal to 0 at x equals 0. Now I'm looking at the interval negative pi over 2 to pi over 2, and the critical value I just found is 0. This is a y prime number line, and I'm going to test t values in each of these intervals. So first, if I test negative pi over 4, I have secant of negative pi over 4 times tan of negative pi over 4. I know that negative pi over 4 is in the fourth quadrant. Secant in this quadrant is positive because that's 1 over cosine. Tan is negative, and a positive times a negative is negative. For this interval, 0 to pi over 2, I can pick pi over 4. So secant pi over 4, tan pi over 4. Since I'm in the first quadrant for this piece, I know that I'm positive. So this has to be positive in that interval. That means that at t equals 0, my first derivative was equal to 0, so that was a critical value. And since I'm changing from negative to positive, that means that y is changing from decreasing to increasing, which means this critical value, t equals 0, is a relative minimum. Now I'm going to find the coordinates of this minimum, so that means I need to find secant of 0, which is 1 over cosine of 0, which is just 1. So the only relative extrema I have on this interval is a relative min of 0, 1. That's it for trigonometric derivative applications. If you have any questions, feel free to leave them in the comments below. Have a great day.